Ah, Mark, I hear the doorbell. I have a friend of mine coming over, help me out with the Magnus force. Let me go get the door. Oh, there's Matt.
Hey, Dr. Collins.
How are you?
I'm good, how you doing?
So Matt's going to help us out today. I'm going to talk a little bit about the Magnus force. Spinning baseballs you've probably seen in the major leagues, curveballs, fastballs, sliders, and so on. So Matt's going to help us out. I'm going to use a beach ball, because Matt, I don't want to hit you in the head with a baseball. Much safer, and you can see the spinning much easier with the beach ball. So Matt, why don't you go over there? We're going to try this out. So Matt's going to be ready. I'm going to be over here. Before I throw this ball, I wanted to talk a little bit about the Magnus force. We talked about Bernoulli's principle. It was pretty simple. We talked about faster moving air versus slower moving air. Faster moving air, lower pressure. Slower moving air, higher pressure. Higher pressure pushes into lower pressure. You can get things to go where you want them to go. What about a ball moving through a fluid? And the ball is not a helicopter blade, but it could be spinning like a helicopter blade. So instead of having the ball move without spin, we're going to put some spin on it and see the dynamics of it as it goes through space. Right? In this case, a gas. When you throw the ball in outer space, it doesn't matter if you spin it or not, you're not going to see these effects. So you need an atmosphere, in this case, a gas. So here we go. I'm going to spin a ball. Before I throw this one, I've got another ball that would be easier for us to see what's going on. Here I've got a string at the end, got the happy face ball. Now we talked about Bernoulli's principle. Now if I spin this ball like this, the fact is we call this now the Magnus force. It's got higher pressure on this side, lower pressure on that side. This ball should tend to curve this way. Okay, so it'll curve this way. Now if I spin it the other direction, higher pressure here, lower pressure here, curve this way, right, as it goes through. Kind of hard to see on the camera, but it will be curving, all right? So, and by the way, if you do spin a ball and try to swing it, you'll see that it wobbles. Well, that's another lecture that we'll be talking about. That's called angular momentum. So in any case, we are going to talk about the Magnus force, sort of a connection of the Bernoulli principle to spinning objects through space. So I'm going to be spinning this ball. I'm going to put a big spin on it, and let's see what happens here. So I'm going to spin it, throw it toward Matt. Let's see what we get. And sort of a hook there. Let's try it again. Okay, thanks. Here we go. Oh, switch cameras there. Let's try that one more time. Ready? I'm going to put a big spin on it. Ah, there you go. See the hook there? Now let's spin it in the opposite direction. It should sweep as we go. Ah, there you go. Okay, let's try it again. It doesn't matter if I throw it up or down. It's going to be spinning across the plane one way or the other because this is the kind of spin. Later we'll be talking about top to bottom and bottom to top spin. So here we're just sweeping it across the plane. That one hit the other ball. Let's try one more time with a big spin on it. Ah, there you go. And then one more here, the other side. Ah, see? So you can see the hook as it goes. Now, what happens if I spin this ball top to or bottom to top, right? So we call it a underspin, all right? You ever play tennis and you have someone hit the ball underspin, hits the ground and kind of dies on you? Or you have the fastball that major league pitchers throw and the batter says, oh, I swear it was hopping through the air. Not exactly correct. It doesn't really hop in the sense that it's rising, but it does kind of hop along the air because you've got a higher pressure on one and a lower pressure on the top, right? So higher pressure on the bottom, lower pressure on the top, so you get this kind of a hop-like effect, even though, again, gravity's always pulling things down. Let's see if I can get this to spin. Will it go and sort of go up? Let's see. Yeah, kind of a nice hook. Easier to see with the beach ball. Ah, there you go again. Let's try it one more try. Again, called the Magnus force. And there you go. It's kind of swooping upward. what if I do it in the opposite direction, going from top to bottom? We call it a top spin. If you ever play tennis and you want to get a top spin, you want to hook the ball from top to bottom and it spins downward. And the player goes, oh my goodness, what a big spin he's got on the ball. So this one should spin and then have a hook downward, sort of go downward faster than it would with just gravity pulling on it. Well, that one went on the bottom. Let me go and get that one. Kind of hard to do because you're trying to throw it pretty straight and it goes down really quick. Ah, there it goes, kind of a hook. And it reminds me I have to go to the beach next week, Matt. He told me I had to clean up all of the soda bottles they left there. All right, one more. Let's try one more. Kind of hard to see on the camera, but try it out at home. I guarantee it's going to happen for you. Oh, sort of like a knuckleball. Matt, throw me your knuckle. Matt's got a good knuckleball, by the way. A knuckleball is really crazy, but still, it's the Magnus force. Ah, all right, so one more. We're going to throw it with the rising fastball, and then I'll see you in the next segment. Here we go. Whoa! Okay, take care. Try it at home. Dr. Bones.